Good evening to all of you and welcome to Augmintech. So first of all, let me know, am I audible for all of you? Clear? Yes, please let me know, am I audible all of you? Give me reply in chat box fast. Am I audible for all? My voice is clear? Okay. So be active, okay, in this group. So here we'll take only 2 hours. Okay, this webinar is of 2 hours. Okay, so don't worry about that. So in this 2 hours, you have to active with me. Okay, whatever I am just talking, just give me the reply. Okay, so as you know that before starting, let's see little bit about myself. See, myself Mohammad Sajjad, and I am an MEP project engineer and trainers. Okay, with several years of experience in industry, I have a deep understanding of technicalities involved in MEP field. Okay, either it is a designing or modeling. And I have done lots of live project also, including residential, commercial buildings. We have also designed the hospitals, buildings, okay, retail stores, malls, and more. So this is all about me. So now, before starting this webinar, all of you know this webinar is HVAC equipment selection. Okay. So before starting, first, all of you listen carefully. I have some announcement. Okay. So in that, the first one is, don't worry about that. We'll provide you the recorded, this webinar recording access link. Okay. So don't worry about that. We have decided to provide the webinar access link to you, but recording access link, but that access link will send you in the last of this webinar, okay, in your chat box. So to get this that access link, you have to stay with us till the end of this webinar, because after the end, I will send the recorded access link in the chat box. Okay, so from there you can easily get the access, so don't worry about that. Second announcement is there, will also provide you the completion of certificate. So for that, what you have to do, that I will explain you, okay, later, so don't worry. And some specials, offers and gifts are also there. So that all we have to discuss in detail, okay, after the completion of this webinar. So before that, now I'm going to start. So all of you are ready for this webinar? Let me know, please give me reply so we can start without wasting time. Yes, give me reply, all of you. Okay. So as you know that we have planned at every week, we have this webinar. Okay. I think many of you have joined my previous webinar also. So in this webinar, we have to discuss about the HVAC equipment selection. So, but here, remember, it is not possible to discuss each and every equipment sizing and selection in this webinar, because this webinar is of 2 hours. Okay. So we have a different equipment like AHU, FCU sizing and selection, chiller, cooling towers, cooling coils selection. Okay. Treated fresh air handling unit selection, fresh air handling unit, and humidifier, dehumidifier. So lots of equipments are there. So today in this webinar, we'll discuss in detail about the air handling equipment sizing and selection. Each and every step we have to discuss in detail. Okay. So now we are going to start here. See, before going to discuss about the sizing, how to size and select the air handling unit, first you have to know about the basic. What is the main purpose of air handling unit? In short, you can say AHU. So what is the main purpose of air handling unit in HVAC? Can anyone tell me in chat box? Yes, please. What is the main purpose of this air handling unit? All of you, again, I'm repeating, please be active. So you will get lots of things from me. Okay. So can you tell me, anyone have idea? Because I know that all of you, some of students are fresher and many of you are working professional. So I think all of you know about that. Ah, yeah, someone are giving me answer. And what about other student? So please be active. So here, first we have to discuss about the main purpose of air handling unit. Okay, their component, and then we start the sizing and selection criteria. So here, The main purpose of air handling unit is given here. All of you can see here. See, can you see this slide is visible? First, let me know. Okay. So here, the main purpose is written, air handling unit condition and distribute air within a building. So the main purpose of air handling unit uh, is condition and distribute air within a building. Condition air. They can distribute the condition air within a building via ductwork. So it is written clear. They take fresh air. Okay. They take fresh ambient air from outside, clean it, heat it, or cool it, maybe humidify it, and then force it through some ductwork around to the design areas within a building. Okay. So the main purpose of air handling unit is what? They take the fresh ambient air from outside, okay, then clean it, heat it or cool it, maybe humidify it. Actually, remember for what location you are designing. For example, in some location, for example, if I take the example of Hyderabad city, which is in India. So in Hyderabad city, when you check the humidity, relative humidity of that city, so from the ASHRAE handbook, you will get the outside design data in detail, okay? Each and every location. So from there, the relative humidity of Hyderabad is around 28%. So we know that as per ASHRAE, how much humidity level we have to maintain? Relative humidity inside the room for human comfort. Anyone? For human comfort as per ASHRAE, always we have to maintain the relative humidity between 50 to 55%. It is depend on which type of space. Like in healthcare facilities, we have some operating patient room. So depends on the space. This all you will get from the, suppose if you want to get this, how much relative humidity we have to maintain. So remember, as per ASHRAE, American Society of Heating, Refrigeration and Air Conditioning Engineers, as per ASHRAE, always for human comfort, inside the room, we have to maintain 50 to 55% humidity. Suppose, let's say if your humidity level, suppose the relative humidity level is low, less than 50%. So what happened? Anyone? We know that low humidity level causes what? Dry skin or hair problems, okay? Respiratory illness, and it can also allow viruses and germs to thrive. Okay, so many different problem you have to face if the humidity level is less than 50%. So remember, make sure you have to see the location as per that. If suppose if you have a humidity level less than 50%, so on that time, generally to maintain the 50% humidity, what we are doing, we are just installing the humidifier. Okay, because all of you know the humidifier is what? Humidifier add moisture to the air na? In HVAC system, in air handling unit. Generally, we are using humidifier to add the moisture, correct? And the next thing, next, suppose for some location, if you are designing where the humidity level is more than 50%, many cities are there, okay? Their humidity level is more than like 70%, 80%. So on that time, what you have to do? So on that time, generally we have to install the dehumidifier. Okay. Because dehumidifier is a device, mechanical device, which just remove the excess moisture, means excess water content from the air. Okay. In the AHU. So this is the main purpose. So here, always remember, we have to maintain 50% humidity level. Okay. For human comfort. So the main purpose, I think all of you understood. So AHU are usually located in the basement or the roof or on the floor of a building. It is depend on the situation. Okay. If you have a mechanical room, suppose you have the architecture have sent you the drawing. So if you have a mechanical room, so better is to install it into the mechanical, which type of AHU you are using. Sometimes we are using floor mounted, ceiling suspended. So it usually located in the basement, on the roof, or on the floor of a building. Correct? Air handling unit are found in medium to large commercial and industrial building. So is it clear? All of you tell me. The purpose of AHU is clear from here. Okay. So now we'll discuss little bit, just in short, the main components of AHU. You can see in this figure also it is given. Here I have taken one schematic drawing of AHU in this image. So here you can see the different component is shown. Can you see the fan, supply air fan is shown, heating coil, cooling coil, even the air filter, different types of filters we are using. Okay. Humidifier, dehumidifier is optional. And outdoor air will we are taking from the back side. Okay. Return air from the bottom. Okay. And from here we are supplying the condition air to each and every room via ductwork. So that all component in short we have to discuss. Okay. Then we start the sizing and selection. So here the first component as I shown you in the image is what? Fans or blower. All of you know that the fans or blower generally moves air through the AHU and the building ductwork. So they can be supply fan or return fan. Okay, based on sometime na in return air duct also, in return side also we have to install the fan. So it is depend on you which type of area. If it is a large commercial area and you want to take the air back to the AHU, you want to take the air. So on that time we are using generally return air fan also. So different types of fans are there. Okay. Like centrifugal fans, generally we are using where it's commonly used for large air volume and higher pressures. So you have to use the centrifugal fan. Okay. Axial fans is used for lower pressure applications, and variable speed fans also we are using. So some AHUs are equipped with variable speed drive. Okay. To adjust airflow based on demand, increasing energy efficiency. Okay, so these are the types of fan. Based on the situation, we have to do the selection of fan. Is it clear? Now, the next component which we have to discuss here is cooling coils. So inside the AHU, we have a cooling coils also. So in summer season, generally this cooling coil is activate. Okay. The main purpose of cooling coil is they cool the air that passes over it. Means they cool the supply air which is coming from the room, return air or fresh air. The main target, we have to cool the air, and that air we have to supply to the each and every room via ductwork. Okay. So the coil typically uses chill water or refrigerant to absorb heat from the air, lowering the air temperature. So here, remember all of you, here I am talking about this centralized AC system, centralized air conditioning, because air conditioning may be classified into two types. All of you know, non-centralized and centralized. In non-centralized, you have seen in your home, like window AC, split AC will comes under non-centralized. Here I am talking about this centralized air conditioning. So in centralized air conditioning may be classified into two types. In that, first is what? DX system. Second one is the chill water system. Centralized air conditioning may be classified into two types. First is the DX system, means direct expansion system. And second one is the chilled water system. In direct expansion system, generally what happens? The supply air cooled by primary refrigerant. Primary refrigerant means the refrigerant which changes phase during the cycle. That is called as a primary refrigerant. So in direct expansion system, if you are using, the supply air is cooled by primary refrigerant. Means inside the coil, you have a primary refrigerant. The refrigerant which changes phase, like R134A tetrafluoroethane, right? Nowadays we are using R134A, R410A. Different type of refrigerants are there which changes phase during the cycle. Okay. So that is called as a primary refrigerant. And the second one is the chilled water system. So in chilled water system, what happened? The supply air is cooled by secondary refrigerant. Secondary refrigerant means the refrigerant which changes temperature during the cycle. For example, water, brine, glycol. Okay. So these are the refrigerant which changes temperature during the cycle. So if you are using inside the coil, if suppose water is running, so that is your secondary refrigerant. With the help of that water, if you cool the supply air, so that is called as a chill water system. Is it clear? So here it is written, the types, we have a different types of cooling coil, like chill water coil, which uses chilled water from a chiller system. Okay. Direct expansion coil use refrigerant directly for cooling. Is it clear, all of you? Understood? Tell me, please, so we can go further. Anyone have doubt in between the class? So you can ask me, okay, without any hesitation. Just in chat box, give the message. I will explain you, okay? Because before starting the sizing and selection, the basic thing is very important to know, okay? Because here I know that in this group, many of students are fresher also, okay? All of them are not a working professional. So that is why I'm just showing the some components. Then we start that main topic, okay? Next thing, heating coil. Heating coil, all of you know, the heating coil warms the air by transferring heat from a hot water supply, stream, or electricity. Is it clear? So here it is given some point about heating coil. Different types of heating coils are there, like hot water coil, which use hot water from a boiler or heat pump system. Okay. Then we have a electric coil, which use electricity to directly heat the air. Steam coil is also there, which uses steam as a heating medium. Okay. So here next component is the filters. Different types of filter we are using. Here I will explain you. The main purpose is what? The filters which we are using, back filter, pre-filters. Okay. Sometime in HEPA filter also we are using in clean room application, like if you are designing for hospital buildings, okay, pharmaceutical, medical facilities. So in that room, generally we are using HEPA filter because in that type of space now, we need to supply the pure air. Okay. And HEPA filter is a special type of filter which purify the air up to 99.97%. Okay. So remember, for clean room application, generally we are using HEPA filter. So filter clean the air by removing dust, dirt, pollen, and other particle before the air is distributed through the building. Okay. Here some type is given like panel filter, which is our basic filtration. Then back filters we are using. Okay. Then HEPA filters stand for high efficiency particulate air. For specialized environment like hospitals and clean room application we are using. Is it clear? So these are the component. MERV rating filters are rated on a scale from MERV 1 to MERV 16 or higher, where higher number indicate better filtration efficiency. That all will explain you. Okay. Next is the dampers which we are using. The main purpose of dampers is to regulate airflow by opening or closing to control the volume of air passing through different parts of AHU. They can be used for fresh air intake, which control the amount of outside air mixed with recirculated air. Then same way you have seen in return air, also we have to install the damper, return air damper, which adjusts the flow of return air from the building. Okay. Then exhaust damper, which regulates the amount of air exhausted from the system. Different types of filters are there. Manual and motorized dampers are also there. Okay. Clear this thing? Then we have a humidifier. It is optional. As I told you, where we have to use the humidifier. All of you, let me know, please. In which, for what situation we have to use? As I already explained you in starting, that humidifier is basically used to, humidifier is a device which adds moisture to the air, okay, in AHU, air handling unit. So let's say if, because for human comfort, we have to maintain 50% relative humidity. Suppose let's say for any location, if you are designing where the humidity level is down, so to maintain the 50% humidity, we have to install the humidifier also. So that is why it is given. It is a optional. So humidifier adds moisture to the air. I will explain you how to select the humidifier, everything, okay, here. So uh, the main purpose, it adds moisture to the air to maintain the desired humidity level, especially in dry environments or climate. Okay, different types of humidifier are there. Steam humidifier, evaporative humidifier. Okay, same way dehumidifier is also given, that is optional. Suppose in some location, if you have a high humidity level, more than 50, 55%, let's say 70 relative humidity or 80%. So in that environment, what you have to do, we have to install the dehumidifier, because this dehumidifier remove the excess moisture from the air. Okay. Different types of dehumidifier is there, that all we have to discuss here. So let's see. The dehumidifier remove excess moisture from the air, important in humid climate. or where humidity control is critical. Example, in clean room, data centers, and more. Is it clear? Now let me know, all of you, please. All of you are clear up to here what I have discussed? Tell me, please, fast. Give me reply in chat box. Don't be keep quiet, okay? Be active. You will get each and everything. Again, I'm repeating because if you are active, so we'll provide you more better knowledge, okay? So remember, again, I'm repeating. Many of students are. So again, I'm repeating. See, we'll provide you the recording class, okay? This webinar recorded access link, but that access link will share you in the end of the webinar in chat box, okay? So you have to stay with us till the end of the webinar. You will get each and every, even we'll also provide you the completion certificate, some special discounts, offers are also there, that also we'll discuss. That all, Asif, I will explain you. Don't worry about it. Here, I am just talking about the basic thing. Asif Akhtar, fresh air, everything I will discuss here in detail. That is why here I am showing only the sizing and selection of air handling unit. Again, I am repeating because that is not possible to discuss the complete HVAC equipment selection. So in detail, we'll discuss the AHU, okay? Sizing and selection. So after the completion of this webinar, I think all of you are able to size and select the HU. So don't worry about that. Let's see now. Some other component is also given like heat recovery unit, that is optional, okay? Heat recovers, this heat recovery unit recovers energy from the exhaust air to precondition incoming fresh air and improving energy efficiency by reducing the load on heating and cooling system. Different types of heat recovery unit is given like plate heat exchanger, heat wheels. Okay. Then mixing box, all of you know, mixing box generally combines return air, which is coming from the building, and fresh outdoor air before sending it through the rest of the HU. Okay. So in mixing box only, we have to mix that all. Okay. Clear this thing now? Yes, tell me please. Now the final is the control system. All of you know the control system automates the operation of the HU, managing fan speed, dampers, temperature, humidity, and overall system efficiency. Okay, sometime it is also connected to the building management system for remote control and monitoring. Okay, is it clear? Tell me please. Then silencer we are using, that is optional to reduce the noise generated by the AHU, fans or moving air. We are using silencer. Okay. Then drain pan. Drain pan why we are using? To collect the condensation that form on the cooling coil. Okay. So these are the some components of air handling unit which we have discussed up to here. I hope that all of you understood up to here. Okay. Is it eight number is the heat recovery unit? Okay, it is the optional one. Okay, so in detail, we have a separate topic for that. Here, it is not possible to discuss in detail. Okay, basically the main function here I have written that it recovers the energy from the exhaust air to precondition incoming fresh air and improve the energy efficiency. Okay, everything we'll discuss. Humidifier selection also. So now let's see. Now I'm going to start the AHU sizing and selection. So all of you now just listen carefully each and every step which I will discuss here. Okay. For the complete selection and sizing. So for the AHU sizing, here you have to follow some step which I will show you here. So what is the step for AHU sizing and selection? In that, the first step is to determine the cooling and heating load. Okay. Cooling load generally calculated based on heat gain, internal and external in this space, including sensible and latent heat. Okay. Then heating load consider for spaces where heating is needed during certain season. So now the question is maybe from where we have to determine the cooling and heating load. So remember, we have a different methods. For manual calculation is also there by using E20 method. Okay. And we have a different software to determine the heating and cooling load. For example, HAP hourly analysis program is one of the software of determining the heating and cooling load. Then Trace 700 is also using to determine the heating and cooling load. Okay, so lots of softwares and O general methods also, because O general, they are using their own methods to calculate the heating load or cooling load value. Okay, so different methods are there. So from the software, you have to determine the cooling and heating load. Now, can anyone tell me what is the main purpose? Why we are determining, why we are just doing the heating and cooling load? Our main target now, we have to find out the cooling load value. In summer season, cooling load value. In winter season, generally heating load value. Okay. Our main target is to calculate the load. Means the HU which we are selecting, how much capacity, how much TR, ton of refrigerant AHU we needs for that space. So the first step is to determine the cooling and heating load calculation. Now tell me, is it clear this step? Fast, give me reply, all of you. Don't be keep quiet, please. Again, I'm repeating. Give me reply. Is it clear? Okay. So now come to next step. Now, the next step which we have to discuss here for AHU sizing and selection is airflow calculation in cubic feet per minute. CFM stand for cubic feet per minute, because here I am just showing you the sizing and selection in imperial unit. Okay. Imperial means if you're working in feet, inch, pounds, so that is your imperial unit. If you're working in millimeter, meter, centimeter, that is your metric unit. So the second step after determining the heating and cooling load, second step is to you have to calculate the airflow rate. Okay. So for that, here we have a formula to calculate the airflow rate in cubic feet per minute. Formula is what? Sensible heat load in BTU per hour by 1.08 into temperature difference. Okay. Now here, sensible heat is the total heat in BTU per, okay. Temperature difference means the difference between the room temperature and supply air temperature. Okay. That is your, and 1.08 is the factor to calculate the, here we are using the factor. Now, maybe many of you in your mind, the question is coming, sir, while calculating the airflow CFM, only here you have considered the sensible heat load. Why you have not added the latent heat load? Remember, while calculating the airflows rate, only we have to consider the sensible heat load, because sensible heat load directly impact the airflow. Okay, directly impact the temperature changes. Na, tell me, is it clear? Yes, tell me. So remember, while calculating the airflow CFM, you have to remember only we have to consider the sensible heat load, because sensible heat load directly impact the change in temperature, which is a function of sensible heat. Na? Latent heat is what? Latent heat is generally related to the moisture removal. Okay, removal of moisture. So don't need to consider that here while calculating airflow. So that is why in the formula it is clear written to calculate the airflow CFM. Formula is sensible heat load by 1.08 into temperature difference. Is it clear now? All of you, let me know, please. Just give me reply. Okay. So now this is the second step. I will give you the example also. Don't worry. Okay. I will take one example also how to do the sizing, everything. So don't worry. Here just I'm showing you the step first. First step is to determine the heating and cooling load. Second, find out the airflow CFM by using this formula. Okay. Now the next step which you have to remember here is coil sizing. Means cooling and heating coil sizing. So remember the coil, cooling coil, or either it is a heating coil. Their size is based on both sensible and latent heat load. Okay, here you have to consider the both sensible and latent load, because here inside the room we have to maintain the comfort, means temperature also, and we have to maintain the humidity also. Na? So here, while calculating, while doing the coil sizing and while calculating the coil capacity, remember it is coil sizing means cooling coil or heating coil is size based on both sensible heat and latent heat load. And here the formula is written, cooling or heating coil capacity formula. To find out the cooling or heating coil capacity based on temperature, your formula is given. So try to understand this formula. Cooling capacity in BTU per hour is equal to airflow rate in CFM into density of air in pounds per cubic feet into specific heat of air, then temperature drop, okay, in degree Fahrenheit. Everything is written. Density of air, all of you know, approx 0.07 point. How much density we have to consider for air? 0.075 pound per cubic feet. And specific heat of air is approx 0.24 BTU per pound degree Fahrenheit. Okay. So airflow rate calculation. Tell me, please. Already I have explained you to find out the airflow rate. We have to use that formula, and temperature drop easily you will get. Okay. Temperature drop means difference. Temperature difference between the inlet and outlet temperature of the air. Okay. That value we have to enter here. Is it clear this point? Yes, please. Yes, tell me. Is it clear? Hi, yes, Amir, you are talking about how to get the supply air temperature. Remember, for that, we have a complete E20 method in each and everything we are discussing. Here, actually, our main target now, I have to show you that how to do the sizing and selection of AHU. Here, we are not talking about the complete heat load calculation. When you perform the heat load by manual calculation E20 method, in that method, each and everything you will get, okay? We have a different procedure for that. Okay. So right now, just see this, what I am just showing here. Okay. So is it clear? So this is the first formula. This formula is based on temperature. Okay. Same way, if you want to find out the cooling or heating coil capacity based on enthalpy. So for that also we have a formula here. You can see. So formula is now a cooling capacity in BTU is equal to 4.5 into airflow in CFM, then delta T, delta H, sorry. Okay. Airflow means the volume of air passing through the coil per minute. Delta H is the change in enthalpy, okay, of the air. Is it clear? And air density is given here. So this formula we have to use. Actually, this factor 4.5 is coming from the conversion factor. Okay. So don't worry about that. Just remember this concept. So we have a two formula which I have shown you. Based on temperature also I have shown you the formula, and based on enthalpy. Is it clear? So you can use it. Which data you have. As per data, you can use the formula to find out the cooling or heating coil capacity. Hope all of you clear up to you. Okay. Anyone have doubts? So you can ask me. Okay, so these are the simple steps which we have to follow. Now, the next step 4, is what? Fan selection. Now, inside the AHU, the fan which we are using, now we have to do the selection of fan. Once you have get the airflow rate and cooling or heating load capacity, if you have calculated, okay. Next thing, the next concept is fan. How to select the fan which we have placed inside the AHU. So for that, simple, here it is given, the fan is selected based on the airflow rate, okay, and the static pressure in the system. So airflow rate CFM already we have calculated in starting in the second step. Now static pressure. How to calculate the static pressure? So remember, for that we have a separate topic. I think all of you know, if you have little bit idea about the HVAC, for any fan, if you are selecting either the fan which you are using inside the AHU or any fan, exhaust fan, always we have to calculate the external static pressure. As a HVAC designer, our responsibility is to do, we have to calculate the external static pressure, because this detail we have to submit to the manufacturer. Internal static pressure value will be given by the manufacturers. Okay. Our main target is to calculate the external static pressure. Okay. So static pressure accounts for duct friction losses, filter resistance, coil resistance, and other equipment in the system. Is it clear? Formula for total static pressure. Suppose if you want to calculate the total static pressure, so same, it is given here. Duct friction loss means first we have to calculate the external friction loss, external static pressure value. You have to calculate the duct friction loss plus filter loss, coil loss, and some other miscellaneous losses are there. So this filter coil loss will be given by the manufacturer side. Okay. Our main target is to calculate the duct friction loss. So for that, we have a separate calculation. Okay. We'll take one webinar on that topic also, how to calculate the external static pressure. If you are interested for that webinar, for the how to determine the external static pressure, so just in chat box, give me message that I am interested. So we'll plan to take that webinar, okay? So if anyone is interested, so just give me, just write down short ESP that I am interested. Okay. Okay, as per that, we'll schedule that webinar also. Okay, here it is not possible because it is a big procedure. Okay. So, okay, now the next step. Okay, many of, I think all of you are interested for that. Okay, so we'll schedule that also. Okay, so don't worry about that. So now fan selection we can do easily with the help of that. Based on the airflow rate and the static pressure in the system, you will get the, if you see, actually problem is what? Here only this two data we have to submit to the manufacturer. Then from the different catalog, you will get the model number and everything. Okay. Next step is what? Filtration requirement. Okay. Different types of filter as I told you. So remember the HU must include filters that meet indoor air quality standards. Means what? For example, MERV rating filters like minimum efficiency reporting value determine how efficient the filter is. Okay. So here we have a different types of filter. See, MERV rating filter. See, MERV 1 to 4. It is the basic filtration. See, it can capture how much particle size is given. MERV range from 1 to 16, I think. So MERV 1 to 4, this is the basic filtration, and the particle size capture 10 to 25 micron particle size it can capture. Okay. Where we are using this type of filter, MERV rating 1 to 4, residential furnaces, basic air filters. Okay. Particle type is the large particles such as dust, lint, and pollen. So they can filter this large particles. Okay. Can capture the large particle. Is it clear? Tell me, please. Effectiveness is given. These filter offer minimal protection and are typically used in low-cost residential air system. So they are not effective in removing smaller particles, okay, or allergen. So for that, you have to select different rating, MERV rating fixtures. So for that also, I'm showing you each and every fixture rating. MERV 5 to 8 rating filter is better filtration, and it can capture 3 to 10 microns. Particle size capture is 3 to 10 microns. Micron means, understood now all of you, 10 to the power minus 6. So see, it can capture 3 to 10 microns particles. Okay. And typically it is better for residential filter, commercial HVAC system. Also, we are using this MERV 5 to 8 rating filter. Okay. And particle types which they capture is mold, spores, pet dander, dust mites. Okay. It's provide a more effective filtration than MERV 1 to 4 rating filter, which I have shown you, capturing smaller particle and improving indoor air quality. Okay. So that is why it is suitable for general residential and commercial HVAC system where air quality improvement is desired. So in that application, you can use this MERV 5 to 8 rating filter. Okay. Next, we have other filter like MERV 9 to 12 rating filters is also there. It is our high efficiency filtration. It can capture up, see how much particle? 1 to 3 micron particles. 1 to 3 microns it can capture. Okay. Particle size capture 1 to 3 micron. And typical application is given here where we can use this type of filter. High efficiency residential system, commercial building, and it is special for healthcare environment. For clean room application, you can use it. Not for clean room, for healthcare environment, this type of filters generally using. Okay. And see the particle types which they can capture. That also I will explain you. Don't worry. Particle types, which type of particle they can capture. This MERV 9 to 12 rating filters, smaller allergens like smoke, fine dust, and certain bacteria they can. Okay. So this filter offers a significant improvement in air quality by capturing smaller particles and allergens. Okay. So here they have given, see, they are commonly used in home with allergen sufferer or in commercial setting requiring better air quality. Then next we have a MERV 13 to 16 rating filters, which is the superior filtration. And the particle size capture sheet is given 0.3 to 1 micron. It can capture that much of a smaller particle. Okay. So see the application where we are using this type of filter. Same hospital, clean room, high efficiency HVAC. So you can say it is a HEPA filter. Okay. And particle size which they are, see, very fine dust they can capture. Okay. So it provides high level filtration and is capable of capturing significant percentage of airborne particles, including some microorganism. So these filters are ideal for environment requiring stringent air quality standard. Okay. So for clean room application, it's best to use this MERV 13 to 16 filter. So is it clear, all of you? Tell me, the selection of MERV rating is clear here. Which type of rating filter we have to use for what application? Okay. So, okay. So here we have discussed about the filtration process. Okay. The types of filter, which type of rating filters we have to use. Some see other ratings are also given here. MERV 17 to 20, HEPA grade filtration. See, it can capture 0.3 micron and is smaller than that much of particle it can capture. Okay. Typically, its application is given a specialized clean room. Generally, we are using this HEPA grade filtration. And the particle, which type of particle it can capture? Almost all particle, including viruses, bacteria, fine pollutants. Okay. It is a HEPA grade filter. HEPA stands for high efficiency. Okay. All of you know that thing. Particulate filter. So high efficiency particulate air filter with MERV rating 17 to 20 provide the highest level of filtration. They are used in environment where air must be free of contaminant to ensure health and safety. Is it clear? Now, choosing the right MERV rating, it is given here. Which type of filter is best for which application? See, generally for residential use, the filtration if you are using MERV rating filter. So for most residential application, which type of filter we are using? MERV 8 to 12 rating filter is typically adequate because it provides a good balance between filtration efficiency and airflow. And if you are using, suppose, if you are doing the sizing and selection of AHU for commercial use, so depending on the industry, commercial building may require MERV 9 to 16 filters, this rating filter. Okay. And for specialized application like clean room application or other environment where air purity is critical. So in that case, we are using HEPA grade filtration. Means MERV 7020 rating filters are used. Okay. Hope all of you clear this thing. Tell me each and every step I'm trying to discuss in easy way. So please let me know up to here. If anyone have doubt in any point, so you can ask me without any hesitation. Okay. I'm available here. That is why in this webinar, I have decided to show you only the HU sizing and selection in detail. So after the completion, you can select and you can do the sizing. Okay. Let's see now. So this is all about the filters which we are using, how to select the filter, selection of filter, that also we'll discuss. Next step is the humidification and dehumidification. So as I told you, humidification, like for spaces where humidity control is critical, such as hospitals or clean rooms. Okay, humidifier or dehumidifier need to be integrated into the AHU. Just as I told you, humidifier is generally used to add moisture to the air in AHU. Okay, and dehumidifier generally we are using to remove the excess moisture from the air in AHU. So depend on the that location or how much relative humidity, how much percents are there. That all you will get from the outside design data. In ASHRAE handbook, everything is given. Based on the location, you will get, they have given the relative humidity that 1 minute. I will show you so you will get the idea. Here I have one PDF. Okay. The data I have taken from the HRE or HRE, I don't know, but see, here it is given. Either you have taken from the HRE or HRE, no problem. Actually, our main target is to see the design data. Just 1 minute. Huh? So let me know, my PDF file is visible for all of you. Yes, please give me reply. So I will show you now. Yes, Syed Kazib, ULPA filters you are talking about, that also we are using for clean room application. Okay. See, uh, here you can see, here I have taken one screenshot of that page. Okay. Now, Vijay, is it clear? This is visible no? Now. I think all of you can view this. Okay, PDF file. Okay. Here you can see the outside design data, which we have taken, I think from HRE I have taken. From HRE also, HRE handbook also you will get. In HRE handbook or HRE handbook, both. So here you can see I have taken only for this some city, some state and station is given here. Andhra Pradesh, for example, which is in India, I am talking about. Okay. Same way in HRE handbook, you will get overall outside design data, which city, which location you want, either it is a India or any country. So here in Andhra Pradesh, you can see the Hyderabad and many other cities is given. So in that, see the latitude is also give based on the state and station, the latitude, altitude, daily range. In summer, what is the dry bulb temperature? See for Hyderabad, how much it is showing? 106 degree Fahrenheit. Wet bulb is given 78 degree Fahrenheit. And see the relative humidity is given for Hyderabad 28%. It means here we know that for human comfort, we have to maintain 50% humidity. It means if you are selecting the HU for this Hyderabad, so we know that we have to install the humidifier also. Okay, because here we have to add the moisture to the air. Okay, so because 28% humidity is, and when you see in some city like Vishakhapatnam, see the humidity, relative humidity is 64%. So it means here we have to remove the excess moisture. Na? We have to use the dehumidifier. So remember, based on the city, here you will get each and everything. So from here, outside design data, we can select each and everything. Is it clear? So now come to our main topic. Okay. So now, okay, I think all of you understood about this. Now here the question is, sir, how we can do the selection, humidifier selection, dehumidifier selection. So let's see. I will show you some step. Okay. So you will understood how to select the humidifiers and dehumidifier selection criteria. So see the humidifier sizing I am showing you. Some step, what step you have to follow. And even I will give you the example also. Okay. Take one example, suppose. So first, let me know my screen is visible. This humidifier sizing PPT is visible. Yes, give me a reply. All of you be active, please. So you can get the advantage of this webinar if you are active. So see here, the step which you have to follow for humidifier sizing, all of you remember. First, you have to know about, we have to calculate the room volume. So room volume generally, to calculate the room volume, simply what? We have a formula, volume is equal to area of that particular room into ceiling height. Simple, you will get the volume of room in cubic feet, correct? So first target is to calculate the room volume. Now the question is, sir, from where we get the area and everything. So don't worry, the architect, if you have an architecture file, so AutoCAD, in AutoCAD software, so easily with the help of list command, you can measure the area of that room. And okay, and from the section drawing, you can easily measure the, or elevation drawing if you have. So from that, you can easily measure the ceiling height. So you will get the room area from that. So first target is to calculate the room area. Is it clear, this thing? In square feet, and ceiling height is in feet. So this first point is clear. Okay. So the first thing, you need to calculate the total for humidifier. If you are sizing for humidifier sizing and selection, first calculate the room volume where you want to supply the conditioner, that room I'm talking about. Okay. Then second step is to determine the air changes rate. This is very important factor here. Air changes rate means ACH value, air changes per hour. Means for that space, okay, where you are supplying condition air, in 1 hour, how many times we have to change the air? Air changes means what? Yeah. Below the ceiling I'm talking about. I don't know your name. See, the ceiling height, why we need to take the ceiling height while if you're calculating the room volume? Because below the ceiling only we have to supply the condition air, na? Above the ceiling we can't, we are not supplying condition air, okay? So that is why ceiling height you have to consider, okay? Don't need to consider the height up to the slab level, okay? Second, determine the ACH value, air changes per hour. In 1 hour, how many times you have to change the air? So it is air changes value is totally depends on the types of building. Okay. Which types of building you are designing. So based on the types of room, select the appropriate ACH value from the table. You can see, yes, recommended air changes per hour values for different types of building is given in this table, which I have taken from the ASHRAE 62.1 ventilation standard, or some recommended ACH value is taken from the ASHRAE 170. Generally, the ventilation for healthcare facility. So here you can see, try to just written carefully, all of you. Here you can see what is given for hospital or healthcare. It is given a recommended ACH which we have to take 6 to 12 ACH. Means in 1 hour, how many times we have to change the air? 6 to 12 times. So better is to take the average one, average value, okay? Same way, if you go for another like operating rooms, so 15 to 25 HEF, patient room, okay? This is all about for hospitals and healthcare. Same way for office building, 4 to 6 times we have to change the air, okay, for human comfort. For classroom, school building. So some of the building based on the building types, the recommended ACH value is given, okay? Now the question is, sir, what is the reference for ACH value? So here, see, reference is given, ASHRAE, American Society of Heating, Refrigeration, Air Conditioning Engineer. So ASHRAE publish ventilation and air quality standard for different types of building. Standards such as ASHRAE 62.1. It is the standards for ventilation standards. Okay. When you open this ASHRAE 62.1, you will get this value. And for healthcare facility, we have a ASHRAE 170. Okay. In ASHRAE 170, the recommended ACH value is given for each and every types of room. If you want to see, I will show you that also. Otherwise, we will tell you that, sir, you have given only the reference. Just see. For healthcare facility, I am showing you. But before that, let me know my screen is visible. This PDF file ventilation of healthcare facility, is it visible? So just open this ASHRAE standard 170. It is 2021 version. So in that now, I think you have to open. See, just 1 minute. Scroll down. See, here it is given. See, when you open this page number, I don't know, table number 71, design parameter in ASHRAE 170. So see here the function of space is given. Can you see? I rooms means airborne isolation room is given. How much pressure we have to maintain in that room. See, everything is written. Negative pressure always in isolation room. Generally, we have to maintain negative pressure. Minimum outdoor ACH is what? 2. Minimum total ACH is also given 12. All room air exhausted directly to outdoor or not? Yes. In isolation room, generally, we need to exhaust all the air. Okay. 100% fresh air we need to supply here. Everything, see. Minimum filter efficiency, which rating filter we have to use for isolation? MERV 14. All of you can hear this thing? Okay, Sujit is telling what is negative pressure, what is positive pressure. So that we'll discuss in detail in our live class, okay? Here, everything is not possible. Even see, Here design relative humidity is also given. Maximum how much humidity you can maintain. Relative humidity in isolation, I room, 60%. And design temperature in Fahrenheit given between 70 to 75 degree Fahrenheit. Okay, same way when you scroll down, many, like suppose if you are designing for patient room, for example, patient room. So in patient room, pressure relationship to adjacent area is not required. Okay, so that is why it is given not required. So don't worry. Minimum total ACH is given 4. Okay, all room air exhausted directly to outdoor not required here. Don't need to. Here we can use that air again. Okay, so don't need to exhaust all 100% air in patient room. I'm talking about. Okay, where is patient room? Here. Even see filter minimum filter efficiency is given and maximum relative humidity, which design relative humidity is given 60%. And how much temperature? Design temperature between 70 to 75 degree Fahrenheit. In degree Celsius, 21 to 24. So is it clear? Yes, tell me please, all of you. So this is all about. So from here, from the ASHRAE 170 or ASHRAE 62.1, you will get this all detail. Okay, ACH value. Okay, so here I have taken some recommended air changes per hour values is given for different types of building. For example, suppose let's say if you are designing for office building, so here they have given 4 to 6 ACH you have to maintain. Okay, all of you. So this is all about the now come to next step. We are talking about humidifier selection. Remember, okay? The first point I have discussed is to calculate the room volume in cubic feet. Once you will get the room volume, now ACH value we need. So from this table, you will get that value. Now the next step is what? Calculate the air volume flow rate. Okay. Now we have to calculate the air volume flow rate. So air volume flow rate is determined by the room volume and the ACH value. When you know the ACH, then only it is possible. So once if you have calculated the room volume in cubic feet and ACH value, you have done the selection of ACH value as per your building type. So by using this formula, or otherwise, if you know the airflow value already, if you have calculated, so you can select that. Otherwise, this formula, room volume in cubic feet into ACH by 60. So you will get the airflow rate. Okay. Then you have to determine the humidity ratio value. Means specific humidity. So how? So remember here, the humidity ratio is what? Is the amount of water vapor in the air. So you can use the psychometric chart, or we have a software also. I will explain you, okay, by using the software to find out the humidity ratio at the current relative humidity. So based on your current relative humidity, what is your current relative humidity and what is your desired relative, means targeted relative humidity. Based on that, we have to calculate the humidity ratio. Suppose if your current relative humidity is 30%, for example, and we have to maintain 15%, desired relative humidity is 50%. Now for both, we have to calculate the, for as per current relative humidity, means as per your current relative humidity, you have to calculate the humidity ratio value from the psychometric software, or if you have a chart from there, or based on desired relative humidity, you have to calculate the humidity ratio value. Once you will get this, now you can easily calculate the humidification load by using this formula. See, formula is what? Simple. Humidification load is equal to Q, means airflow rate, which we have already calculated, into W2 minus W1. What is this? Same. Q is the volume airflow rate. W1 and W2 are the humidity ratio at the current and target relative humidity respectively. And 4.5 factor is what? It is the conversion factor to account for air density and time. Okay. So remember 4.5. So these are the formula which we have to use. So now I will take one example, a small example. If let's say you want to calculate the humidifier, see, first let me know my blackboard is visible, all of you. Yeah. So I will take one small example for humidifier selection, how you can select the humidifier. So suppose let's say here, first let me know the application. Suppose the building type, here the building type is any building you can take. Suppose I'm considering building type is office building, let's say. Okay. So the building type is office building. Okay. Now, suppose for that, for which location you are designing, suppose let's say Hyderabad. Okay. So from the outside design data in ASHRAE handbook, it is given. Suppose for Hyderabad, how much relative humidity? So I'm just considering, suppose my initial relative humidity uh, for Hyderabad or any other city is 30%, I'm assuming. Okay. And desired humidity is what? How much we have to maintain as per you? Tell me, please. As per ASHRAE, how much relative humidity we have to maintain? So the desired relative humidity we have to maintain, let's say 50%. Okay, all of you know. I'm considering 50%, let's say. Okay, building type is office building. Initial relative humidity is 30% and we have to maintain 50%. So desired relative humidity, I have written 50%. Next thing, what is your office space? Suppose this is my one office space. Just example, okay? Total area of this space, I'm considering, let's say, 15,000. Total volume, suppose, let's say, 15,000 cubic feet. I'm considering. So the volume of space is what? Tell me. 15,000. Because this detail you will get from the drawing, okay? 15,000 cubic feet I have considered. Now tell me, to calculate the humidification load, what is the formula? All of you let me know, please. What is the formula to calculate the humidification load? Airflow rate Q into W2 minus change W1 into 4.5 factor. So if you know the initial relative, desired relative, volume of the ACH is important. ACH is important. So let me know for office building, how much ACH, air change in 1 hour, how many times we have to change the air? Yes, let me know, please. See, in this, I have already discussed. If you see, it is given for office building 4 to 6. So let's say I'm considering 6 maximum. Better is to consider the average one, 5. Okay, so suppose in my calculation, I'm just considering 5. In 1 hour, we have to, how many times we have to change the air? 5. Okay, from that table. Now, the formula to calculate the humidification load, formula is given here clearly. Okay. Now, let me know. First, I will show you how to calculate the airflow rate. So for that, formula is what? All of you tell me in CFM. Volume of that space in cubic feet into ACH value, air changes per hour, by 60. So can you tell me, volume of our space is 15,000 cubic feet. ACH, we have taken 5, then 60. Just open the calculator and let me know the value. Someone is telling 1250. I'm also checking. 1 minute. 60. Okay. So here the airflow value which we have got is Q value 1250. Unit is cubic feet per minute. Okay, CFM I have written. Next, the value which we need is W2 and W1, means humidity ratio value. So based on your initial relative humidity, you have to calculate the humidity ratio value, and based on your desired relative humidity, calculate the humidity ratio value. So I'm opening the next page. So first, let me know what is our initial relative humidity? 30%, na? And 30%. And see, here you have to know about the dry bulb temperature also from that location, for which location you are designing. So suppose for Hyderabad, let's say example I'm taking. So the dry bulb temperature for Hyderabad is how much? Ambient temperature is important here, okay, for the humidifier selection. Suppose any temperature, just, sorry, not outside temperature. I'm not talking about outside temperature. Again, remember, I'm not talking about, because here inside the room, how much temperature we have to maintain as per ASHRAE, as per human comfort? See, remember all of you, always, yeah, Azim, you are right. 23 degrees Celsius, and in Fahrenheit, near about, we can't say exact, but 76 plus minus 2 degree Fahrenheit. Okay, near about. Okay, so let's say I want to maintain 75 degree Fahrenheit. Okay, inside the room, we have to maintain 75 degree Fahrenheit. Now, based on this initial relative humidity and this dry bulb temperature, we can get the value of humidity ratio. From where? From the ASHRAE, psychometric chart, or if you have a software. So I will show you with the help of software. See, here I have psychometric software. Can you see my page? Software is visible. When you open this software, here you will get this type of interface. Other student, what you are doing, please be active, all of you. See, here the psychometric analysis is written. So to continue, hit on continue first. And the next thing, first of all, now, always, before doing this, always we have to select the sea level first. For your location, what is the sea level? So for Hyderabad, I have shown you, let's say, again, I am just showing you in feet I want, okay? See, this is your outdoor design data. So when you see in Andhra Pradesh, Hyderabad is in India, okay? One of the city. So for Hyderabad, you can see the altitude is given here, 545 meter. So can you convert this meter in feet and let me know, please, all of you? Yes, Prem, let me know. I think all of you know the conversion factor formula. 1 meter is equal to 3.28. So near about 1787, I think. Yeah, near about 1787 feet we have got here. So now open your software. First of all, from this software, you have to select the sea level. So our sea level for Hyderabad, it's coming how much? Less than 2,500 feet. Na? Sea level is less than. So you have to select the carrier number first only. So if let's say in case, if you're designing for any location where the sea level is 2,500 feet or more than that, so you have to select the second number. But in our case, I have selected carrier number 1. Now from here, state point and processes, hit on that. And now hit on add points. Okay, here you can write down the city name. For example, I am writing Hyderabad. No problem. Just write down Hyderabad city name. Now what is your here now? Only 2 properties you have to enter. If you know any 2 properties of air, any 2 properties. So based on that 2 property, you will get all the remaining other property. Let's say if you know the dry bulb temperature and relative humidity, when you enter these 2 properties of air here, remaining all other property, humidity ratio and many other properties, specific, everything you will get. So in our case, can you tell me inside the room how much we are maintaining? 75 degree Fahrenheit. Remember here the temperature which we have to enter in degree Fahrenheit. Because see, when I am taking the cursor, it is showing. We have to always enter the temperature in 75. Now we know the relative humidity. Initial, so from here, select the relative humidity and write down. Initial relative humidity is, I think 30%. So I am just writing 30%. See, when I have written, I have entered the 2 properties of air. See, the remaining all other properties is showing you. Can you see? The humidity ratio is how much now? 38.7. Am I right? But see, this 38.7 in which unit? Grain per pound. But in this formula, the relative means the humidity ratio value which we have to enter is not in grain per pound. Okay, I will show you. So whatever you have selected, just select it. And finally, you have to hit on apply. See, when you hit on apply, here you will get the psychometric software. Can you see this software? All of you let me know, please. And you will get the exact location. See, this curved line in this psychometric chart, you can see the curved line is showing. I think it is properly visible or not. Let me know. This curved line is representing humidity ratio, relative humidity in percentage. See, 90% lines, 80% line, 70%, 60%. This all curved line is representing relative humidity. Okay. And when you scroll down, see, here we have some 40, 45. This vertical line is representing what? Tell me, please. This vertical line representing the dry bulb temperature. In psychometric chart, remember the vertical line representing the dry bulb temperature, curved line representing the relative humidity. Okay. Many others see the horizontal line representing what? Dew point temperature. Okay. So our main target is not that. Our main target is we know the dry bulb temperature and river. So you can see uh, here we have got one point which is in 30% line. See 20%, 40% between this curved line is showing. This is 30% curve. So here we have got one point and the temperature which we are maintaining 75. So we have got the point. Based on this point, when you take the cursor, this see the horizontal line, here you will get the value. See, this is your humidity ratio value in which unit that is also given here. Okay. So try to understand all of you. See, pounds of moisture per pounds of dry air. We need the humidity ratio value in which unit pounds per moisture per pounds per of dry air. We don't need in grain per pound. Okay. That is why I'm telling. I want the value of, in formula, the value which we have to enter for humidity ratio is pounds of moisture per pounds of dry air. So can you tell me, as per our situation, can you tell me how much value we have to consider for humidity ratio? Just draw the horizontal line. See, it is near about 0.06, 0.006. Can we take? Tell me, please, all of you. Can we take 0.006? Because both are intersecting in this point. Na? So here, as per that, initial we have got relative humidity. W1 value how much? 0.006. Okay, and their unit is written clearly. Now, can you tell me the desired relative humidity is how much? 50%. And here also dry bulb temperature is same, 75%. Okay. So as per that, I want the humidity value, W2 value. So, okay, same thing. Now what you have to do? Just open that table again, which I have minimized. Can you see this one? Now here, you have to enter now. Okay, dry bulb is clear, but the relative humidity is now 50%. After applying this, just hit on apply. Now minimize, see, you will get the point here. Can you see? Now this point is in which curved line? In 50% curved line. Can you see? This is our 50% relative humidity line and 75% we have to maintain the temperature. All of you know. See? So the point are coming here. Means the relative humidity and 75° Fahrenheit will intersecting here. So just draw the horizontal line and let me know how much humidity ratio value now we have to consider. Between 0.009 to 0.01. So I am just using 0.01. Okay. You can take 0. Better is to take more than that. Okay. 0.01. Don't need to take 0.09 because it is coming between that. Na? So 0. How much? 0.01. Na? Am I right? Tell me, please. So now I am applying the formula because already we have calculated everything. So the humidifier to calculate the humidification load. Tell me the formula, all of you. Let me know, please, in chat box. What is the formula? We have to use Q value airflow rate W2 minus W1 into 4.5. So airflow rate, how much we have calculated? You can see the previous page for that. 1250 CFM. Okay. So write down here 1250 CFM and W2 value 0.01 minus W1 0.006 into 4.5. Let me know the value how much we have got. 1250, sorry, 0.01 minus 0.06 into 4.5 into, yeah, anyone have done? Only 2 student are active. And what about other student? Please give me reply, okay? 22 point, yeah, 22.5. Means near about 23 I am just taking. And unit is, remember, kg per hours. Sorry, not kg, pounds per hour, okay? Everything we have taken that na pounds per hour. It means what? 23 pounds per hour means what? Means the means the humidifier which you are using, that humidifier needs to add 23 pounds moisture, water vapor content. Needs to add 23 pounds moisture in 1 hour. Okay. To get the how much humidity? 50%. Okay. So 23 pounds per hour. How much moisture? They can add 23 pounds moisture in 1 hour to get the desired relative humidity 50%. Okay. Understood all of you? Tell me, please. Now the sizing concept is clear. Humidifier, how to select, how to do the humidifier sizing. Tell me fast. Give me reply, all of you. Same way you have to use same process. Same process is there for dehumidifier selection. Let's say I'm showing you, if you want to select the dehumidifier, so same process is there. Suppose now I'm assuming next page, just let's see. Suppose for any location, if you are designing, okay, to calculate the dehumidification load, formula is what? Listen carefully, okay? This each and every topic which I am showing you, you will search it anywhere, you will not get this thing in detail which we are showing you here. So it is very important. All of you try to understand, okay? You will never get this detail anywhere, okay? Even lots of webinars are there, but no one will give you in-depth knowledge about in this way you have to perform all these things. So that is why I'm telling, may be active. So you will get, now let me know, formula is same, Q, W1, now the W1 minus W2 into 4.5, okay? Now suppose, I'm just assuming, here also same, we are designing for office building, building type is office building. Suppose now the initial relative humidity is 80%, I'm assuming. Okay, for any location, suppose the initial relative humidity is 80%. And desire, because then desired relative humidity, how much we have to maintain? 50%, let's say, okay? And dry bulb temperature, you know that same, 75. Okay, degree Fahrenheit. So if the initial humidity, relative humidity 80%, so that is why we are using dehumidifier here, because we have to remove the excess moisture from here, na? Ha. So just same way, you have to substitute, first calculate the W1 value. Just in the psychometric software, you have to enter the 80% and 75%, you will get the W1 value, same way, desired relative humidity, and this one value you have to enter, then you will get W2. And airflow rate, same concept. Volume of room in cubic feet into what? ACH divided by 60. You will get the Q value. Substitute, you will get the dehumidification load. Okay, in pounds per hour. Is it clear? So in this way, you have to do the selection of humidifier and dehumidifier. I hope all of you now clear this. Okay. So here I'm talking about the HU sizing and selection. So in HU, for what are the steps which I have discussed? The first step I have told you, we have to determine the heating and cooling load. Okay. Second step is to calculate the airflow value. Okay. By using formula. Third step, tell me the third step. Cooling and heating coil capacity by using the formula I have shown you, based on temperature, based on enthalpy. Both formula I have discussed. Then filter selection also I have discussed. Okay, MERP, different types of rating filter I have shown you, which type of filter you have to use. Okay, after that, about the fan selection, in fifth step, I think we have discussed about the fan selection also. So for that, our main target, external static pressure, because based on static pressure and airflow rate, with the help of different catalog, you will get the different model numbers, size of fan. And second, next step, step 6 is the humidification and dehumidification. Okay. So how to select, how to size the humidifier, dehumidifier selection criteria, that also I have discussed with you. Now the next step, is space consideration. Remember, these are some detail which we have to submit to the manufacturer, okay, for the HU. So here, can you see what is given here? All of you let me know, please. Fast. Space consideration means what? Yeah, fast. Give me reply. Don't be keep quiet, all of you. What is mean by this space consideration? See, uh, ensure that 1 minute, yes. When you are placing the HU, so you have to remember how much space you have to maintain between the room and HU. Just my screen is visible na clearly. Tell me, please. So ensure the selected AHU fit within the designated mechanical room, or let's say if you're placing in mechanical room, so okay. So you have that much of space or rooftop space, including clearance for maintenance. So now the question is here, how much clearance we have to maintain? Okay, that also it is given. Yes, very good, Sydney. They have they have done the calculation for dehumidification load. So in this way, all of you, if you are active now, so you will get lots of information from me. Okay. Same. Next thing here, the clearance which we have to maintain, it is given. Provide adequate clearance around the HU for maintenance, service access, and airflow. So here it is given a minimum of 3 feet as per 3 feet. I am just doing as per experience. For that now, for spacing, as per manufacturer recommendation, minimum 3 feet distance we have to maintain on all site of AHU. For what? For maintenance purpose, for service access, or for airflow. 3 feet minimum clearance we have to maintain. Now, is it clear this point? Tell me, please, give me reply. This point is clear, all of you? Okay. Now, let's see the next point which we have to discuss here. Step number 8, energy efficiency. So it means what? Here, actually, we have to select the component like the fan which we are using for energy efficiency, the fan, whatever fan inside the HU which we are using with variable frequency drive, VFD, to optimize energy usage, particularly when operating at part load. Okay. Then next step is the noise consideration. How much noise we have to maintain? So the noise reduction may be necessary, especially for AHU located near occupied area. So use low noise fan, sound attenuator, and vibration isolator to manage the sound level. Okay. Here you can see the sound noise criteria rating is given. Okay. The noise criteria rating is commonly used to define acceptable noise level in indoor spaces. Okay. Lower noise criteria rating correspond to quieter environment. For example, 25 to 30 decibel noise we have to maintain for libraries, conference room, if you're supplying conditioner in this type of room, residential area. So between 25 to 30 and 35 to 40 decibel for open offices or commercial space, you can go up to 40. Okay. Maximum you can go up to 45 also. So the HU design should aim to meet this noise criteria rating to ensure the comfort of building occupants. Okay. So if you want to get if you want more detail about the noise criteria, so for that you have to follow the ASHRAE guideline to meet acceptable noise level in different types of space based on use. Okay, it is given in ASHRAE, everything is given. So the standard provide specific noise level recommendation for HVAC system. Okay, in which room, how much for commercial. So generally, here I have given you the idea. If you are designing for residential or this type of space, so go for this one range. Okay, if it is an office or commercial space, better is to maintain maximum the noise criteria 40 decibel. Don't go beyond that. If it is a shopping mall, okay, so on that time up to 45 decibel you can go, no problem. Okay, clear this thing, tell me please. So these are the points which you have to remember. Now here I am taking one example. Here I have shown you everything. What is the criteria? What are the steps which you have to follow Now see one example, AHU sizing and selection example I am showing here. Okay, so all of you be active now and listen carefully. Here I am showing you the example so you will get the idea. So in this example, see, let us go through an example to understand the AHU sizing process. Suppose the building scenario, we are designing for office building, okay, with a total, suppose we have done the cooling load calculation, okay, with the help of software, suppose HAP software, Trace 700 or manual heat load calculation by E20 method or general methods are also there. So here the building scenario is given office building with a total cooling load. Total cooling load means they have given the sensible. Here I am just showing you the sensible load, okay? Because to calculate the airflow, only we need the sensible load, na? So the total cooling load or sensible load value is given here, 1,20,000 BTU per hours, okay? 10 ton. Is it clear? Desired room temperature means inside the room, how much temperature as per ASHRAE for human comfort, we have to maintain 75. Not exact, but between 76 plus minus 2 degree Fahrenheit, okay? So 75 is the best, okay? So 75 degree Fahrenheit temperature we have to maintain for human comfort. So desired room temperature here. Supply air temperature, suppose 55. To calculate the supply air temperature, remember, again I am repeating, we have a formula for that, okay? See, I will give you the example from where you will get. Actually, in manual heat load calculation, we are teaching each and everything. How you will get the supply air temperature value. Here I have considered 55 degree Fahrenheit, but from where we get this value? Maybe someone is asking me also, I think. So see, I'm showing here. Just wait, give me 1 minute. So we'll show you that. Let me know my screen is visible, all of you. Actually, it is not given here. One minute. We'll show you now. Yes, my screen is visible. Let me know, please, so we can continue. For that, okay. Let's see. Here I am showing you in E20 method. Generally, we have that how we'll calculate the supply air, everything. I have discussed that. 1 minute, huh? Supply air. I'm not getting here. 1 minute, just wait. Okay, so here I'm not getting that space sheet. In that, I have discussed everything. See, I think, here it is given. See, all of you let me know, please. My screen is visible. To calculate the supply air CFM, see all of you. The table is given here. First, you have to know about the capacity. If you know the capacity, based on this capacity, you will get the supply air CFM value, supply air temperature value. See, first now you have to calculate the apparatus dew point temperature. Once you will know the apparatus dew point temperature based on capacity, these are the formula which you have to use. Suppose let's say you have done the cooling load calculation and you have got the value around 10 ton or 9 ton, let's say 10 TR. Okay. So for 10 TR, if you want to calculate the supply air temperature, see the formula is written, apparatus dew point temperature plus 8 degrees Fahrenheit. So calculate the apparatus dew point temperature. For that also we have a long procedure. Okay. So in heat load calculation, we are teaching this thing. Okay. So here normally I have shown you, this is the way to calculate the supply air temperature. Now I think all of you get the idea. Okay. So now come to our main topic, which we are talking. So here I'm talking about the HU sizing and selection example. So the building scenario is given, office building, their cooling load value is given 1,20,000 BTU per, okay, means sensible load. Desired room temperature 75, supply air temperature is also given 55 degree Fahrenheit. And here see one point is given, space required 30% outside air, because suppose the air which you are taking back, means from the room, the air which you are taking, the return air, that all return and only we have to clean it, that return air, then cool it, and then we are supplying that. But also we are taking the outside air, fresh air also. So here they have given space required 30% out. Here we are done the assumption. I have assumed that 30% outside for ventilation. But remember to calculate the fresh air, and the total building area is 10,000 square feet. How you will calculate the fresh air requirement? How much fresh air? Suppose for which space you are designing, let's say any classroom. For example, in classroom, if you want to supply the conditioned air, okay, so the return air which you are taking from the classroom, that plus we are not taking 100% return air from the class. Some amount of air we have to exhaust to the atmosphere. Because if you take again and again that return, that air again and again if you take, so problem is what? Actually, inside the room, we have to maintain the comfort environment. Okay. So many problems you have to face. So that is why now we are not taking 100% return air from this space. Some amount of air we have to exhaust it to the atmosphere. So to maintain that air, we are supplying fresh air. Now, how much fresh air we need to supply, how you will get. So first, always, all of you just try to understand exact I'm just talking about, because here I have assumed 30% outside air for ventilation. I'm just assume here, assumption I have done, but exact calculation I will show you here. For that, simply, first you have to know about what is actually fresh air. So to calculate the fresh, anyone? See, fresh air means what? Atmospheric air sucked by a machine, either it is a AHU, FCU, it is called as a fresh air. Simple. Clear? Who? Clear or not? Tell me. So fresh air is a necessity for both physical and mental health. In some building, what happens if indoor air is recirculated? So due to which what happen, impurities may be breathed in again and again, which include indoor pollution and higher level of carbon dioxide level. So here, this will create poor indoor air quality. So our main target is to maintain the air quality. So to avoid this, fresh air is supplied as per the number of occupants and the area of this space. So according to ASHRAE 2004-62.1 ventilation standard, to calculate the fresh air CFM, here the formula is written. Can you see? CFM per percent means outdoor air per percent into number of people plus CFM per square feet into area. So by using this formula, you can easily calculate the fresh air CFM. Okay, now I will take one example so you will easily understood. Let's say here one question is given. Here what we have to do, we have to calculate the fresh air for classroom. Okay. Inside the classroom, suppose plus 9 ages students are there in this classroom, and the area of that classroom is 600 square feet. Now, if you want to calculate the fresh air CFM for this classroom, how much fresh air we need to supply? So we have a formula, as I told you. What is the formula? CFM per percent into number of people, okay, plus CFM per square feet into area. Now the question is, sir, from where we get this value? Outside air or CFM per percent? CFM is the unit, okay, outside air I'm talking about. So from where we get the CFM per percent value? Yes, anyone? Same from the ASHRAE ventilation standard, ASHRAE 62.1 ventilation standard, you will get the CFM per person value based on your space type, which type of space you have. If you have a classroom, so as per that, you will get the CFM per person value, whatever space you have, office, dining, any space. Okay, that I will explain you. Okay, so the CFM per person value you will get from the ASHRAE ventilation standard. Now, the next one is the number of people. So remember, number of people as per furniture layout. Let's say if in your architecture drawing, which you have got from the architect site in AutoCAD, if suppose the furniture layout is also given, so as per furniture layout, you have to decide the number of people. For example, in classroom, if suppose they have given the desks, table, furniture is there. So just you have to count that furniture. As per that, you have to consider the number of people. So let's say in some cases, you know that furniture layout is not given. So if it is not given, so you have to ask architect or interior decorator or for to client for this number of people, how many number we have to consider, because exact idea we don't know, na. We have to design, but exact idea we don't know. But let's say suppose if they have also not given any data for the number of people. So in the last, we have one option from ASHRAE ventilation standard. We can also calculate the number of people. Maximum how many number of people will be there in this 6,600 square feet area in classroom. That also I will explain you how to calculate. Okay. As per space, you can easily calculate. Same way CFM per square feet value you will get from the ASHRAE ventilation standard. So let's see now. This is our classroom plus 9 ages students are there. So here I have shown you one table in this in front of your screen. So you can see when you open the ASHRAE ventilation standard, in that standard, you will get the minimum ventilation rate in breathing zone table. I think I don't know the exact table. Okay. See, I will show you. Actually, just see from here. I have taken the screenshot. So see in the first column, the occupancy category is given. Can you see the correctional facilities, educational facilities? Under that, under this educational facility, see the classroom age 9+ is given. All of you can view this. So for classroom age 9+, CFM per person value, how much we have to consider? 10, and CFM per square feet 0.12. Even to find out the occupant density, number of people, it is given for 1000 square feet. For every 1000 square feet, how much total people maximum you can consider? 35. So if for 1000 square feet, 35 student, so can you tell me in our classroom area 600. So for 600 square feet, how much total number of people we need? Let me know. If for 1000 square feet, simple, see, it is very simple, all of you. If you know that it is given clear for 1000 square feet area, number of people is given 35. No? So above classroom area is 600 square feet. So for 600 feet, how much X? Do the cross multiplication and calculate the area, X value, number of people. Tell me, anyone have done? Near about 1 minute, 35 into. Yeah, right. Total. So in our case, total how many people we have? 21. So in this way, you have to calculate the number of people, CFM per person, CFM per square feet value. Now, I hope all of you clear this thing. Now, I am substituting this value in this formula. So from the table, we have got how much CFM per person value? 10. Is it clear? And next, CFM per square feet 0.12. Okay, from this table, same way. As I told you, for 1000 square feet, 35. So for 600 square feet, 21 people we have got. Now just substitute this all value in this formula. So you will get, I think, just substitute 282 CFM. For classroom plus 9 ages student, how much fresh air is required? 282 CFM. So exact calculation is this. Okay. So now I think all of you clear this thing, fresh air calculation. Okay. Now come to our main topic, which we are discussing. So here I am assuming 30% outside air for ventilation, let's say, and total building area is given. So now, can you tell me the first step is what now here? Calculate the airflow CFM by using the formula, simple. That formula already I have discussed. Here the sensible load 1,20,000 BTU per hour. So when you substitute this and the temperature difference is what? All of you understood now? Suppose inside the room which we have to maintain is 75. Desired room temperature is 75 and supplied temperature 55. So near about 20 degree Fahrenheit. Now use the formula to calculate the airflow CFM. Formula is what? Sensible heat load in BTU per hour by 1.08 into temperature difference in degree Fahrenheit. Is it clear, all of you? Let me know, please. Am I right? Formula is correct. Now, just substitute the value. See, sensible heat load value I have written 1,20,000, which we have got from the heat load calculation by 1.08 into 20 temperature difference. So as per that, I think 5,556 CFM airflow rate we have calculated as per our building scenario. Okay. Now the next thing, once you will get the airflow rate, next thing is what? Next. So the AHU should handle the AHU which you are selecting. So it should be handled 5,556 CFM of airflow. Now the next detail which we have to submit to the manufacturer is we need to determine the outside air requirement. Okay. So here we are assuming for office building 30%, but exact calculation I have shown you. Okay. So 30% of that total we have got 5,536. 5,556. So 30% is 1,000. Yeah, 667 CFM near about. Okay. So just determine the outside air requirement. So AHU must bring in that much 1,667 CFM of outside air. Now in third step, cooling coil capacity. So formula I am using simple. Let's say we know the enthalpy difference delta H value between supply and return is 6 BTU per pound. Okay. So easily, if you know the enthalpy and airflow formula is what? 4.5 into airflow value into delta H. So delta H, here we are assuming 6 BTU per hour. So as per that, see how much cooling capacity we have got? 1,49,022 BTU per hour. This is our cooling capacity. So this detail we have to submit to the manufacturer. Okay, remember, first thing, airflow, CFM, second, outdoor air requirement, cooling coil capacity. These are the detail which we have to submit. For the selection of AHU, these are the detail, okay, which we have to submit to the manufacturer. As per that, they will give you the model numbers, supply air outlet size, return air outlet size. That all I will explain you, okay, from where actually. No, Sydney, I have told you, na, here I have assumed 30%. Exact calculation of outside air requirement, I have shown you the formula, na? Tell me. I have shown you the formula for exact calculation, okay? So don't worry about that. Here I am just assuming 30%, so don't worry. Yeah, Sayyid Kasif, I have explained you while calculating the airflow, only we have to consider the sensible heat load. Why? Because, tell me anyone, because airflow directly impact the temperature changes in a space, na? And that is a function of sensible heat. So we have to consider the sensible heat load. Don't need to add latent heat load here. Okay, while calculating the airflow. Because latent heat is related to removal of moisture. So don't need to consider here. In case of cooling coil capacity, when you are calculating on that time, you have to take both sensible and latent heat. Okay. But here, see, I have only taken the sensible airflow rate. Sorry, it is clear. Okay. Now, next thing, step 4, fan selection. So for that, if suppose airflow requirement, we have calculated 5,556 CFM. So for that, you have to assume duct. Suppose here I have done the assumption because I have told you we have to do the external static pressure. Okay. So let's say assume duct friction loss, filter losses, and coil resist reluctance lead to a total static pressure loss of 1.5 inch of water in our case. Okay. So the fan selected should deliver 5,556 CFM at 1.5 inches of water gauge static pressure. Then filter selection. All of you know, here we are talking about the office building. So we have to select a filter with a MERV 13 rating to meet office air quality standard. Clear? That all I have discussed in detail. So a higher MERV rating increases static pressure. So make sure the fan can handle the additional pressure drop. So these are the detail which you have to submit to the manufacturer. Once you will submit this detail, AHU manufacturer, so they will give you this data. See, can you tell me my AutoCAD file is visible, all of you? Here I will show you one of the AHU manufacturer. See, here we have a different size of AHU, their model number, everything. See, first, this is one of the manufacturer, Syntec, AHU manufacturer. So here you can see when you submit this all detail now, which I have shown you. Okay. So when you submit, so as per that, they will give you the, see, which type of double skin or inner skin value, everything, outer skin density, panel thick, and see the capacity 17,000 CFM. Even static pressure value, see, that is why I'm telling you static pressure, and this all value you have to see. Coil type, DX or chill water, motor, 3 HP motor, fan model is given here, AHU sizing is given, total length, width, height. Even you can see the fresh air opening size is also given with volume control damper, 320 by 320 mm. Return air opening size is also pre-filter size, coil size, MV filter size, supply air opening size, bypass, access door. You can see this is the plan view. From the top view, the AHU will look like this. Can you see? Same way, if you see the AHU from the elevation section view, see, this is your, here everything is written. This is your return air opening, return air duct opening. Okay. Clear? This point number 2 is your return air duct opening. Point number 1 is the fresh air opening. Okay. Then point number 3 is the pre-filter. Point 4 is the cooling coil. And point 7 is what? Bypass. Even point 8 is given here. What is access door is shown here. Okay. The fan is visible here. This is 6 point is what? Supply air opening here. You can connect the supply air duct from here. Okay. Even different size of different capacity of AHU, 6,900 CFM AHU, their size is different. Even we have a 1,000. Okay. So they will give you this detail. Suppose in your project, if you are using multiple AHU of different capacity, so you have to submit this detail. As per that, they will give you the sizing, each and every data. All of you clear this thing? Tell me, please. Is it clear? So this is our complete AHU sizing and selection criteria. Same way, we have different equipment we are using in our project. You know that HVAC equipment like FCU, chiller sizing, selection criteria, cooling tower, treated fresh air unit, fresh air handling unit sizing, humidifier sizing, each and every. So I have told you in starting that is not possible to discuss every means complete HVAC selection in this webinar. So that is why what we have decided here recently we have launched a complete HVAC equipment selection pre-recorded course. Okay, you can see. I will show you because we know that many of the students are working professional. You do not have that much of time. So here you can you see my screen is visible? Tell me. Here recently we have launched this topic, this course, okay, in our website, HVAC equipment selection. So here what you will learn, it is given, see. Total, see the access, total more than 5 hours video lectures are there, okay. And the access enrollment validity is 1,000 day. And you can see the regular price is given 9,999. This is the regular price. But today, we have a special offer for you, okay. Same course, only for today. And you have only last 20 minutes. Today, the special discount I will give you for this course. Same course, you will regular price is 9,999 means around $100. But for this webinar student, we have some special offer. Same course you will get in 3,909 rupees, means $49. Only $49. And for this discount, you have a last 20 minutes. If anyone are interested, to enroll for this course, I am sharing you in your group. Just all of you check it. I will share you the payment, INR payment link and USD payment link also in your group. So with the help of that link, you can easily enroll in this course. Okay. And this offer is only for last 20 minutes. Again, I'm remaining. After this 20 minutes, right now it is 9:20. You have only 20 minutes to enroll in this course. Okay. So the payment link is also shown. Sure, INR payment link is also shown. Send you in the chat box. You can see, and USD payment link. So if you are from India, you can use that INR link. Okay. So only you will get the course in 3,999, means $49. Only in 49, and you have a last. You have a last 20 minutes for this offer. After that, same course you will get in 9,099. That is why I'm telling this is the best opportunity for you, because no one will give you in-depth knowledge like this for HVAC equipment selection. Here I will show you what are the topics which we have covered in this complete HVAC equipment selection. Okay. So let's see. Here, this is our HVAC equipment selection course. Here you can see, first of all, we have explained the complete in detail air handling unit introduction. Also, we have discussed the component and everything. Okay. Then AHU sizing and selection criteria in detail. Then FCU fan coil unit introduction, components, their sizing and selection criteria in detail. Even the chiller sizing selection, their component, what is the main purpose, and how we have to select and size the chiller in detail. We have discussed that in Excel sheet also I have shown, and manual calculation also I have shown you. Same way, cooling tower selection also, introduction, types of cooling tower, their component, their some special terminology which we are using in cooling tower, okay, like range, approach, everything we have discussed. Then cooling tower sizing and selection step, example, with the help of example also we have discussed in detail. Okay. And treated fresh air handling unit. One more thing, again I'm sharing that link. Suppose if anyone are facing any problem, if you have any question or need further assistance, so feel free to reach out us. I will send you in chat box. See, I have sent the WhatsApp number only. No, see, Hari Shankar, I'm talking about this course, HVAC equipment selection course. Okay, here what you will learn that I am showing you in this screen. So if you're facing any problem in enrollment, so you can check the WhatsApp number is also I have sent in your group. Okay. And the INR payment link, USD payment link is also shown. Discount payment link. You can use that link to enroll in this course. Okay. And if you have any doubts, so you can contact into the given WhatsApp number. Okay. And see, here I have also shown you the treated fresh air handling unit selection, their function, component. Okay. Fresh air handling unit selection criteria also we have discussed. Cooling coil selection also you will get in detail. Okay. Okay. My name is Mohammed Sajjad. Okay. So I have sent you, and remember, as I promised you in starting, that will send you the recording access link also. So for that, you have to wait it for 5 minutes. I will send you the recorded access link also in this chat box. So if you want the recording, so just wait 5 minutes. I will send you the recorded access link. And to get the completion of certificate, that also I will show you what you have to do. Okay, so don't worry about that. Okay. So here, no, I am talking whatever we have discussed now here as per ASHRAE. Everything, the selection criteria, which we have discussed here. No. Here, next thing, see the humidifier selection is also given. But right now, I have not uploaded this video because we are working on it. Okay. After 2 days, you will get this also. Humidifier selection in detail, dehumidifier selection criteria. So in future, we'll add also. So don't worry about that. Right now it is 5+ hour courses. We'll have in after 1 hour, 1 day we'll upload that also. Humidifier selection, dehumidifier selection. So if anyone are, this course is recently we have launched this course. Okay. So I think this is the best opportunity. If anyone are interested, you can just enroll it. Okay. So last 5 minutes, see the people are enrolling. Sohail Khan is already enrolled in this HVAC equipment selection course. So don't waste your time. Okay. And see, remember, you can access the course after enrollment. You can access the course content through Augmintech website in 24 hours. Okay. So for that, just if you are interested, again, I'm sharing the link. You have last 15 minutes for that. See, the link is in your chat box. And let's say if you're facing any problem, if you have any question or need further assistance, so just fast and hurry up and contact into this given WhatsApp number. Okay. And I am also sharing the link of this HVAC equipment selection course. So you can use that. But in that link, the course is different. You can see the course syllabus, whatever it is given in that link. Okay. Is it clear, all of you? Anyone have doubt? Anyone facing any problem? So you can ask me, please. We are available here. Last 15 minutes you have, okay? In starting, I have told you. Yes. So now, as I promised with you that in the end of the class, we'll share you the HVAC equipment selection webinar recorded link to you. So that also will share you. And if you want for certification of completion, see in chat box. For in chat box, see all of you, I have shared one email. You have to email it here for certification of completion. And to get the HVAC equipment selection webinar recorded link, here I am just sending you the link also, okay, in group. So you can use that link to get the access. Just wait for 2 minutes. After that, we'll send. Yeah, because people are enrolling. So just wait for them. Yeah, if anyone are interested, don't be just think so much, okay? Just only you have to only 3,999 rupees you will get this complete information. So that is why I'm telling, I'm repeating again and again. So go through that. Okay. And for certificate of completion, I have sent the email. You can use that. Just send your name to this email number. Okay. You will get. No, so in last week, I think Usman, you have not sent the mail on that. I think you are not available in the end of the class. That is why you are facing that problem. Now that is why I have sent the augmintech@gmail.com. Just use that email. Yes, anyone have any doubt? So you can ask me regarding this enrollment or course detail. Let me know. See, complete what we are providing, that is here. 5+ hours video lecture, even internationally recognized certificate of completion. Ebooks are also there. Multiple Excel sheets are there. 1,000 days access is also there. Okay. So I think this is the best opportunity. So just use the link and enroll it fast. Last 10 minutes you have, all of you. No, so if see, remember AMM, everything I have discussed in detail only. Okay. From the catalog, it is depend on you now, which catalog you are using. Your company are using which catalog, would manufacturer. As per that, you have to do this. Actually, here I have shown you the selection criteria, exact model number and everything you want. So for that, you have to submit this all detail to the manufacturer. Na? Different manufacturers are there. USD just only $49. Afzal, you will get this course only in $49. And this offer is last 10 minutes is remaining for this offer. Okay. After that same course, you will get in 9,900, means near about $100. Okay. So that is why I'm telling only for this webinar student, we are giving this offer, special discount offer. So if you are interested, just enroll it. Okay. Don't think so much. Everything we have discussed here in detail. And if anyone have a confusion, suppose you are facing any problem during the enrollment. So I have also sent the WhatsApp number also in your chat box. So you can use that WhatsApp number. Yeah. Yes, Sohail Khan. This is only 3,900 and 999. See, the sir is sharing the link. Okay. Go through that and buy it. Now I'm sharing, as I promised with you, that I will share you the webinar recorded access link. So I'm sharing that link. So you can use that link to get the access in your chat box. Yes, Premsha, you have to email for certificate. Already I have shown you the. Okay. So here the equipment selection is given. No, in MEP designing and drafting, we have not covered. So just go through that. In this, that much detail, we have not discussed in that. Okay. Here I have the see, I have discussed each and everything. The topic is front of you. I'll observe. So go through that. So last 10 minutes is there. Okay. All of you just hurry up. So don't worry. Once you have got the access now, all of you just access you will get after 1 hours. Okay. We'll upload the recording soon. So don't worry about that. Access you will get after 1 hours. Okay. And HVAC equipment selection webinar recording link I have already shared. No, Asad, you have to mail it into the given email which I have sent you for certificate. Okay. Again, I am just sharing that in chat box for certificate of completion. Just mail it. You're talking about in live class. ECV, you're talking about in live class. And remember, again, I'm repeating. Yeah, of course. In that class, we'll cover, but not complete. Complete equipments are not there. Okay. But we'll discuss that in live class. Don't worry about it. Already in live class, we'll discuss. If you have already enrolled in our live class, MEP designing and drafting, in that already, don't worry. We'll discuss that all. Okay. So just hurry up. You have only last 8 minutes for enrollment. Go through that. Enroll it now first. Last 8 minutes is remaining. Okay. Again, I'm repeating recorded access link you will get after 1 hours. Okay. We'll upload the recording soon. So be patient for that. So if anyone are interested, so you can enroll it in this course. You have last 8 minutes. So go through that fast. And if you have any question, so that you can ask me. I'm available here. Anyone have question? So no one will teach you in this way. So that is why I'm telling this is the best opportunity. After that same course you will get in 9,009 means in $100. So it is depend on you. Losses you are talking about, HEPA filter losses. So remember that is given by the architect, that manufacturer side. Okay, we can't say like this. How much losses will be there? So that you will get from the architect side. Okay, sorry, not architect, manufacturer side. They will give you this information. Coil, how much losses in the coil, that all. Yes. Thank you, Asif Akhtar. Yes, all of you, just you have only last 6, 5, 7 minutes are there, okay, for this discount, special discount offer. If you are interested, so just enroll it fast. Yes, last. Remember, again, I am repeating, this offer is only for this last 20 minutes that I have already discussed in starting. Okay, after that, you will not get this course in this amount, 3,999 rupees, $49. This offer is only for last 20 minutes, only up before the meeting is end. Okay. After that, tomorrow you will get same course in $100. Again, I am repeating. Okay. So don't, if you are interested, you can just today only you have to enroll. And I know that some are traveling. So, but this offer is only for this last 10 minutes. Either you are suffering or traveling, whatever. Okay. After that same course, you will get. So who are interested, they are enrolling in this. So if anyone are interested, just go to that. Last 5 minutes you have. So already many students, Tayyab, Chai, and Tayyan have enrolled in this course. What about other? Just go to that. If you have any further, suppose you are facing any problem, suppose any problem. So that I have a that's why I have shared the WhatsApp number also. Just right now only you have to contact into the given WhatsApp number. Okay, if you are facing any issue and you have any question, go to that and contact. So each and everything, each and every equipment we have discussed in detail. Okay, here. One more time, I'm sharing the webinar recording access link. You can use that link to get the access. Yes, if again I'm repeating, anyone are facing any issue regarding payment, so you can just contact into the given WhatsApp number, okay? If you are facing any issues regarding payment or enrollment process. So see, again, I'm sharing the WhatsApp number. Just contact into the given WhatsApp number for that. Last 5 minutes are there for this offer, okay? After that, same course you will get in $100. Yeah, who is this 704? Just contact into given WhatsApp number if you're facing this type of problem. Why your account is not working? So if you have PayPal, so you can contact to the WhatsApp number. You can do the payment through PayPal also. We have other option also. Okay. So what is your name? Can you tell me your name? 70. Just contact into the given WhatsApp number if you're facing any problem. Don't think so much, all of you. If you are interested, just go through that. Okay. Each and everything you will get in detail. And in future, we'll also add some other topics also, equipment. Like humidifier is not given here. That also we will add humidifier, dehumidifier selection, everything. Yes, Afzal, you are talking about that. I cannot pay right now. I use my credit. You can just do the payment through PayPal, na? We have that option also. Other student, if you are not getting, we have other option also. Okay, can payment through PayPal. Okay, if you are facing any problem in this, otherwise just contact into the given WhatsApp number. So yes. So fast, if anyone are interested, just go through that fast because you have only last 5 minutes for this offer. After that, same course you will not get in this amount. The discount is only for last 20 minutes. Okay. Actually, remember for fresh air, na Kasip, for fresh air calculation, I have already explained you how you will get the exact. You're talking about thumb rule, exact calculation. We have a formula. Okay, fresh air calculation formula I have already explained you. CFM per percent to number of people plus CFM per square feet into area. Okay. Same way, once you will get the fresh air and supplier CFM, you know that supplier CFM from the uh, heat load, whatever how you have calculated from the heat load calculation. So if you calculate the return air, how much return air? So supply minus fresh, that is your return air CFM. Okay. Actually, here it is not possible now, okay, in this webinar to discuss each and everything in detail. But then also I have discussed everything in detail, okay? So if you want more detail, if you are interested for complete, so we have a live class, pre-recorded class of HVAC, okay? You can go through that. Both option is available. Okay, so I think now our time is gone. Okay, the time is gone. So only 1 minute's last 1 minute is remaining. If anyone are interested, so you can just enroll it. Okay. 3,990. After that same course, you can see in front of you, it is given 9,990, $100 you have to pay. Okay. So last 1 minute is remaining. After that, we'll end the meeting. Hi, yeah, in live class we have discussed. Don't worry, ECV. Tell me your name, please. You are there in live class, MEP Designing and Drafting live class. Yes, in that class we have discussed. Don't worry about that. In that we have discussed. Okay, Arvin Villa Hermosa. Okay. So, okay, so this is all about the HVAC equipment selection. I hope all of you enjoy this session. See you in next one. Goodbye. Thank you to all of you.